For part D, we have the logarithm of x, the natural logarithm of x, is equal to 5. The natural logarithm is base e, so to undo taking the natural logarithm, we need to exponentiate both sides base e. On the left-hand side, the exponentiation base e undoes taking the logarithm base e, and that just leaves us with the argument of the logarithm, which is x, and on the right-hand side we'll be left with e to the 5th power. So the solution to our equation is e to the 5th power. Just as before, we can check our result on our calculator. First of all, we store e to the 5th as x, which is approximately 148.413. Next, we go back to the original equation and evaluate the left-hand side and make sure that it is equal to the right-hand side. We see that the natural logarithm of x is equal to 5, which matches our original equation, and so we've solved the equation correctly. For part E, we have the natural logarithm of x plus 1 is equal to 3. To undo the natural logarithm, we'll need to exponentiate both sides base e. On the left-hand side, the exponentiation base e undoes taking the natural logarithm, and that leaves us with the argument of the logarithm, which is x plus 1. So we have x plus 1 is equal to e cubed. Finally, to solve for x, we take away 1 from both sides, and that gives us x is equal to e cubed minus 1. We can check our answer just like we've done before. First of all, we store e cubed minus 1 as x, which is approximately 19.086. Then we go back to the original equation and evaluate the left-hand side to make sure that it's equal to 3. We see that the natural logarithm of x plus 1 is equal to 3, and therefore we've solved the equation correctly. For part F, we have the natural logarithm of x minus the natural logarithm of x plus 1 is equal to 4. Unlike parts D and E where we had a single logarithm, here we've got 2. We have the difference of two logarithms. So what we'll do is to use one of the properties of logarithms that says that the difference of two logarithms is the logarithm of the first argument divided by the second argument. So this becomes the natural logarithm of x divided by x plus 1 is equal to 4. Now we can exponentiate both sides base e as we've done before, and we'll end up with x over x plus 1 is equal to e to the 4th. To undo the division, we can multiply both sides by x plus 1. That gives us x is equal to e to the 4th times the quantity x plus 1. We can then use the distributive property on the right-hand side. Next, we take away e to the 4th times x from both sides. Factor out an x on the left-hand side. And finally, divide both sides by 1 minus e to the 4th. So our apparent solution is e to the 4th divided by the quantity 1 minus e to the 4th. So we go ahead and check our solution just like we've done in the past. And we see that our solution is approximately negative 1.019. We go back to our original equation and evaluate the left-hand side to see if it is equal to the right-hand side, 4. In this case, we get an error message, non-real answer. Notice that we have the logarithm, the natural logarithm of x. Since x is a negative number, the natural logarithm of x is undefined. Therefore, our apparent solution of negative 1.019 is not a solution. This equation does not have any solutions to it.